What if the most important part of a stealth aircraft isn't the engine, but the tiny details hidden inside the manufacturing process? A gap smaller than a coin, a perfectly aligned panel, a surface smoother than it looks to the human eye. In stealth aviation, machining isn't just about making a part fit, it's about making an aircraft almost disappear. Behind every sharp edge and mysterious black surface is an enormous engineering challenge. Today we're going inside the manufacturing world of stealth aircraft to discover three critical machining principles that help make these machines so difficult to detect. Instead, stealth aircraft are designed to reduce the signals that make them easier for radar and other detection systems to find. That means the shape, surface, materials, and even the way individual components fit together can matter enormously. And this is where advanced manufacturing becomes essential. A conventional aircraft can tolerate certain imperfections. A stealth aircraft has much less room for error. Its exterior geometry must be carefully controlled because unexpected edges, gaps, or surface changes can affect how electromagnetic energy interacts with the aircraft. The first machining secret is simple: precision. Modern aerospace components can be manufactured using multi-axis CNC machines capable of controlling complex shapes from multiple directions. Instead of moving a cutting tool along only three basic axes, advanced machines can rotate the workpiece or cutting head to reach difficult surfaces. Why does this matter? Because stealth aircraft contain highly complex components. A single aerospace part may have curved surfaces, pockets, holes, and extremely precise interfaces. The goal isn't simply to remove material, the goal is to remove exactly the right amount of material while maintaining the intended geometry. After machining, those components can be inspected using precision measurement equipment. Coordinate measuring machines, laser scanners, and other inspection systems can compare a physical component against its digital design. In aerospace manufacturing, the difference between looks correct and is within specification can be enormous. The second principle is something most people would never notice: surface consistency. Imagine looking at a stealth aircraft from a few meters away. Its surface may look perfectly smooth, but underneath that surface is a huge amount of engineering work. Aircraft structures are made from many individual sections. Those sections have to meet precisely. Manufacturing teams work to control dimensions, alignment, fasteners, joints, and surface transitions. The objective is to avoid unnecessary discontinuities in the aircraft's carefully designed outer geometry. This is especially challenging when engineers combine different materials. Stealth aircraft can use advanced composites alongside metals and other specialized materials. Each material behaves differently during manufacturing. Some expand differently with temperature, some require completely different cutting and finishing techniques. The third principle involves the material itself. A stealth aircraft isn't simply covered in ordinary paint. Aircraft designed with low observable characteristics can use specialized materials and coatings as part of their overall design. These materials have to survive vibration, temperature changes, moisture, ultraviolet exposure, and extreme aerodynamic conditions. That creates another manufacturing challenge. The surface must be prepared correctly before a coating or protective layer is applied. Even small imperfections can become important when the aircraft depends on a carefully controlled external surface. And there's another fascinating detail. Manufacturing doesn't end when the CNC machine stops. Aerospace production is a continuous cycle of machining. Inspection, assembly, testing, and rework. Engineers measure the part, compare it with the design, identify deviations, and make sure the final assembly meets extremely demanding requirements. So when you look at a stealth aircraft, you're not looking at just one incredible machine. You're looking at thousands of manufacturing decisions working together. The geometry has to be controlled, the components have to fit, the materials have to perform, and the surface has to remain consistent. That's the real machining secret of stealth aircraft. There isn't one magic machine or one mysterious material. Stealth is the result of precision engineering repeated thousands of times. From a CNC cutting tool moving through titanium, to a technician checking a microscopic deviation, every detail contributes to the final aircraft. And sometimes the difference between being detected and remaining hidden can begin with something as simple as a perfectly machined surface.